Hello, friends. Really excited to be with you here today. Today, wanted to hop over and work through an exercise right quick. This exercise is called Divisible by 2 or 3. Today, we're working out of Chapter 10 of Daniel Liang's Introduction to Java Programming. Now, problem 10.16 is divisible by 2 or 3. Find the first 10 numbers with 50 decimal digits that are divisible by 2 or 3. Cool. Let's pop over here to Eclipse and let's get started. So I've got a whole lot of other fun stuff that I've been working on inside the same folder I'm calling Chapter 10, Section 9. So I'm just going to add another one because this is still using the big integer class. I'm going to add a new package. I'm going to call this Chapter 10, Exercise 16. So we'll go ahead and create that, and then inside that, I'm going to make a new class, which I'm also going to call Chapter 10, Exercise 16. Now, I'll include a public static void main so that this thing is executable. Let's go ahead and get this thing fired up. Make sure that it will run, and it does. And then let's go ahead and see if it'll stop. Yep, it will. Now, next thing I want to do is I want to include the question itself, so we don't have to bop back and forth just for the question. Now, we'll bop back and forth for a few other things, I'm sure, because there's a lot of good information in the book. But the question itself, let's go ahead and grab that and make sure that we don't have to worry about going and finding that again. Sometimes I get the sequence wrong on what's when you're supposed to hold the shift key down, and I get it backwards, and that's always funny to me. All right, so find the first 10 numbers with 50 decimal digits that are divisible by 2 or 3. All right, so the thing that makes this interesting is the with 50 decimal digits part. Okay, so here's what I want to do. Let's just grab this, and let's do this. First, and let's paste this in here, and let's find the first 10 numbers that are divisible by 2 or 3, because I'm kind of good at this and I can think through some of these. 6 is going to be one of those numbers, so that should be first on the list. Then divisible by 3 and even, well, I know 12 is going to be there, and then probably 24 and 48. So there are going to be some numbers in there. 96, because I'm just taking 6 and multiplying it by 2. Maybe you can yeah, I think the 6 by 2 will work. I don't know. Anyway, let's get that part of the code working first. And then we'll circle back and then work with 50 decimal digits. Okay, so let's do int numbers to find equals, let's do 3. And then let's do find numbers int divisor 1 equals 2, int divisor 2 equals 3. And you know what? To make this less confusing, we're going to make this a 4, right? Okay, and now we'll do, let's do find our evenly divisible numbers. And we're going to pass it number divisor 1, divisor 2, and then we'll pass it numbers to find. Okay. Now, I hope The only thing it's complaining, our integrated development environment is complaining about is it don't exist. It doesn't. So we can make it. Cool. Okay. So I don't actually want to return anything because if I'm honest, I'm not going to do anything with the list after I create it. I just want to create the list. So let's just test this out. Hello from inside the method. Cool, so we didn't break that. That's always good. Now, let's pop down here and let's say for int starting number let's do this a little bit differently. And I'm cheating a little bit. I'm thinking about problems that I don't actually have yet, which is always a very stupid idea. And as my daughter, my 6-year-old will point out, we don't say stupid. So int starting number, let's start with 1, you know, because math. And then let's int offset equals 1. You know what? For loop ain't gonna cut it. For loop ain't gonna do this. We don't want a for loop. We want a while loop. So let's do int offset equals 1. Okay. Now keep running equals true. Oh, by the way, I was thinking a Boolean there. Thank you for keeping me honest, Mr. Integrated Development Environment. Excuse me. While, keep running. So we've got a nice little for loop or a while loop we can work inside now. And so let's do this. Let's do Boolean. First number, hit, let's just call it hit, equals false. And we'll call the second one, because I'm creative, let's call it second number hit. And so basically these two are gonna go true whenever we've got a match. So while Boolean keep running, if we'll do starting number, nope, let's do this. And then int current value equals 0. And so we'll come in here and now we can say, all right, what's our current value? Our current value equals our starting number plus our offset. Okay. If 0 is the same thing as our current value modulo, and then we've got the buzzer 1 up here. Okay, so if this is true, then we can say equals true. And then we'll come down here and I'll say else, brackets, false. You probably need to tell it just a little bit more than that. You know, because like it can't read my mind much as I try. No matter how many hours my computer and I spend together, it still just hasn't figured out. It doesn't get me. It doesn't read my mind. Okay, so we've got that. And then we'll come down here. Now, I'm going to change this to 2. And then I'm going to grab this second number hit. And I'll say there, and there. Okay, so now we can say if first number hit and second number hit, then sys out oh, not current number, current value. Okay, so I did a whole lot of programming and very little of mashing the button to make it go, go, go. And I'm gonna say I've already done something wrong because it's not that hard to come up with 6. Oh, there's an important step in here. So at the bottom of this, we need to say offset, let's see. Offset plus plus. Got that running. Hey, oh, you know what? Now we've got that working. Did it find 6? Yeah, it went too long, right? So now we have to fix this. So probably let's come up here and then let's add the current value and let's do int. Number of findings equals 0. Come in here, and I'll have this, and I'll be like, hey, if we printed one off, number of findings, let's make that one bigger, and then offset plus plus, and then I'll also come down here and I'll say if number of findings is now greater than, actually greater than or equal to numbers to find, then did I use keep going? Was that what I used? No, keep running. My apologies. Keep running is now equal to false. Okay, let's see if that fixed it. Hey, and there's 6. Turns out I missed 18, but 6, 12, 18, 24. Cool. Now, we've got enough to get started, right? We've got the basic mechanics. We've got all the math worked out. Ugly? I'm not gonna lie. It's a little ugly, but we know that it works, right? And so we've got a few things that we can come in here and we can start to play with. Okay, so everything that we're using as a integer, we need to now change over to be a big integer, right? I know, I'm also excited because big integers, sometimes they get a little complicated. So let's look back. So this was chapter 10, listing 9. This is how you can take this is how you can do some stuff, right? And so I think the first thing that we need to do is we need to change the starting number to a big integer. And my plan is basically this. I'm going to go blow stuff up by changing out every integer that I can with a big integer as slowly as possible. And when that gets done, I'm gonna know that I got it running. Now, that being said, because I've screwed up things like this before, I'm going to show you how I slowly work through this without losing my mind. And one of the keys on this discussion is going to be, don't delete it, comment it out. Okay, so my divisor 1, divisor 2, numbers to find, those are relatively small numbers. We're only looking for a total of 10 for this problem, 10 numbers to find. It's divisible by 2 and 3. I'm going to leave those as integers. I'm not going to complicate my life that way. I don't need that kind of drama today. But the starting number, I think it needs to be a big integer. Now, how do we make a big integer of 1? Let's, we could go back. Instead, let's just grab this, because I think this is going to work great. So I'm going to copy that. You know what? It's actually the same spot, different tab. And I'm going to comment this out. End there, big integer. I'm going to call it the same name, starting number, and I'm going to keep it as 1. Now, should be a whole lot of problems with that, right? It says, hey, you know what? Your offset is no longer correct. Okay, so we'll take this, comment it out, go to end, and then I'll do big integer offset equals new big integer 1. Cool. Okay, and now it says, oh, this is not defined for this kind of thing. So if you want to add these two numbers together, that's perfectly fine, and you can do that. You just can't do that this way. Okay, so let's see if we can pop in here. Dot multiply, no, it doesn't look good. Divide, multiply, divide, multiply. Daniel, you got anything up in the book there, buddy? So we'll pop back up here to the big integer class. We've got use add, subtract, multiply, and divide. Okay, so let's see if we can do that. We'll come in here and we'll say, let's do, instead of creating current value up here, I'm going to go ahead and get rid of that. And what I'm going to do here, let's do big integer, current value equals starting number dot add, and then we'll add our offset. No. All right. The integrated development environment knows what I need to do. It's trying to help me. Okay. Now, this is probably, what's it say? Operator modulo is not defined for big integer. Cool. Okay, so let's walk through this. The first thing we need to do, I think I remember there's an example. Nope, those are just punching them in. Yeah, so this is how we can make that index into a big integer. So that's just going to go. Let's see, make a little space here. I'm going to comment out this line. I'm going to copy it. If 0 equals current value modulo divisor 1. Okay, so we've got the same problem again. I'm going to paste in that little line of code. Cut this out here. It's not actually indexed. So let's see if we can just get away with this. Dot mod, yeah. So delete that. Okay. And now we need, let's see how crazy we can get. Big integer dot 0 dot equals Okay. So I'm probably short of parentheses. Yeah. Cool. So it says if big integer dot 0 equals current value dot mod new big integer divisor 1. Cool. All right, so now we got to do the same thing down here. So let's go ahead and grab this. Home. Pop this off as a comment. Now, this is why it's fun to be my little deranged self sometimes, right? I'm actually just going to come in here and then we're going to make this 2. And then let's save it. Let's run it. Oh, offset plus plus. Ah, you know what? That's not going to work, right? So we've got to do offset dot add, and then we're going to do big integer dot ONE. Yeah, buddy. Okay, that seems like it's a little less upset with me, which is good. I mean, we want to be friends. Hello from inside. Okay, that's, okay, I have concerns. This should not be taking this long, right? So I'm going to cheat just a little bit. I'm going to say my starting number is 5, right? And then let's run it. Okay, 6, 6, 6, and buy. All right. I still have an offset. All right, I'm gonna be honest. I'm not real sure what's happening right there. So SYS, sys out. Okay, so that makes me think offset dot add big integer dot 1. Offset 1, 6, finds it, offset 1. Okay, so I don't feel like it's doing what it's supposed to be doing there, right? Let's do this. Let's grab this. I'll just make that an integer like that. No, still not happy. Okay, let's do this slightly different way. Let's do int offset equals 1. And then we come down here. Let's copy that because I'm going to use it a little bit here. I'm going to come down here and I'm going to do int offset plus plus. And then new big integer Let's see if that changes. Nope, still not. Well, okay, you know what? Okay, so our int offset starts out, then it goes to 2. Offset down here stays 1. All right, let's do add, let's do big integer value of int offset. Okay. It just does not seem to be liking that add. Okay.
I don't want to go to party.
Cool.
Yeah.
Let's try this. Let's do big. Let's just grab this line here. Int offset equals 1. I'm just going to cut this out of here. So our int offset is equal to 1. We're going to come down here, and I'm going to say big integer. Let's see if I can get away with this. Dot value of, no. So let's see. No. Yeah, let's try this. New big integer. And so we'll just do new big integer of, like this. And then come up here and offset plus quotation marks. Change that. Cool. Okay, come down here. Those were not working anyway. They're just mostly aggravating me, so I did. Hey, cool. Now we've got lots of stuff. It seems to be doing stuff, but I've got so many print statements that it's now confusing me just a little bit. All right, hello. Let's start changing some things back to where it was. 1. Let's do, get rid of that print statement. Okay. I think that might have been the one that's causing me weirdness. Hey, there we go. 6, 12, 18, 24. And those are all using big numbers. And that's what we got before. So I should have probably copied and pasted the old code and done these in 2 different classes so that I could have compared the results and played around with them. But now let's start having some fun, right? So we can go in here, number defined, let's go up to 10. Make sure that this is working. Okay, 6, 12, good, 18, 24, I can agree with all those. Yes, 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 yes. Cool. Okay, now we do the other part. This is our starting number. Our starting number, according to the problem, now we're ready to do 50 decimal digits. So one of the ways that we can do that, the first number with 50 decimal digits, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So there should be 49 zeros and a 1. 1, 2, 3, 4, 5. Good. 1, 2, 3, 4, 5. 2 of them. 1, 2, 3, 4, 5. 3 of them. 1, 2, 3, 4, 5. 4 of them. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5. 7. 1, 2, 3, 4, 5. 8. 1, 2, 3, 4, 5. 9. 1, 2, 3, 4. Maybe I needed an extra 0 in there. At this point, I will admit the numbers are getting a little fishy to me. 2, you know what? That might be divisible by 3. But just to kind of check this right quick, I'm going to grab this. I'm going to come up in here down to scratch paper land where nothing should run anyway. And I'm going to space this just a little bit. 1, 2, 3, 4, 5 space. 1, 2, 3, 4, 5 space. 3, 4, 5 space. 1, 2, 3, 4, 5 space. 1, 2, 3, 4, 5 space. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So there should be 10 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. So what it came up with is this little block of numbers. And I like that. That's pretty exciting. That's pretty cool. So just so everybody that gets a copy of my code has everything up and running. Oh, it doesn't like it when you do that. You gotta help it out just a little bit. There we go. Let me just paste this in here right quick. Cool. All right, friends. So anyway, I had some fun working through that problem. It took me, I feel like it took me a little bit to get my head wrapped around the big integer. And just a reminder, what I was running into here, that is an immutable object. Like, I don't know why it wasn't just letting me add to it like I wanted to, but that's obviously more reading that I need to go do. Eventually we were able to get something up and running, and so I'm pretty pleased with that. So with that, thank you all for your time and have a wonderful day.